Okay, hi everyone. So now we're going to learn section 1.4, which is rational expressions. So rational expression is a fractional expression or quotient in which both the numerator and denominator are polynomials. So here we can see x minus 2 is a polynomial, and technically 4 is a polynomial with like an x0 power. X squared plus 1, and then the quadratic equation on the bottom is also a polynomial. And then 4 over x2, those are all rational expressions. So with rational expressions, we are often concerned about the domain. So the domain is the set of real numbers that the variable is permitted to have. So as a rational expression indicates division, and division is not allowed, there are some numbers that we cannot plug into x or whatever the variable is, because that'll make the denominator 0. So for example, we have 4 over x minus 2 and 9x over x squared plus 3x minus 18. So go ahead and think about those and think, what can't I plug into the bottom that will make the denominator equal 0? Okay, so we're going to go ahead and look at the domain together. So we don't want the denominator to equal 0. So we're going to see when it does. So it equals 0 when x is 2. So our domain is going to be x such that x does not equal 2. And then our other expression, we're going to have to factor the bottom to see when it equals 0. So we have negative 18 and 3. So we have 6 and 3. So 6 times 3 is 18, but we want it to equal negative 18. So I'm going to go ahead and put the negative there because we also want 6 plus negative 3 to be 3. So we rewrite this. And we can see that the denominator is 0 when x is negative 6 and x is 3. So our domain is that we're going to want x such that x does not equal negative 6 and x does not equal 3. So simplifying rational expressions, we're going to want to factor the numerator and denominator completely. And then we're going to want to divide out common factors and simplify. So here, I have this expression, and I'm going to factor it. So factored form is x plus 5 times x plus 1, and then we have a difference of 2 squares. So that's x plus 5, x minus 5. So here we're able to cancel out our x plus 5s. So we're left with x plus 1 over x minus 5. And the domain for this, we don't want x to equal 5 because here it'll equal 0. But also we don't want x to equal negative 5 because it zeroes out here. So in general, we want to make sure throughout our process when we're trying to get to the final answer, check to see what's on the bottom because there might be other things that can make the expression 0. So when we're multiplying rational expressions, we also want to factor. And then we want to divide out common denominators or divide out common factors and then multiply across the numerator and the denominator like you would in fractions. So here we have x minus 7 over x minus 1 times x squared minus 1 over 3x minus 21. So we're going to go ahead and factor. So we could factor our x squared minus 1 and then factor out a 3 from the denominator as well. So here we can see that we could cancel some things. So we could cross cancel the x minus 1 and then the x minus 7 as well because when we multiply them, those will be the numerator and denominators that we could cancel. So we're left with x plus 1 over 3. So what's the domain here? So our domain is x such that x does not equal 7 from this one, and x does not equal 1 from this other one. And that's our domain. So in dividing rational expressions, we have a over b divided by c over d. And so the rule for this is flip the second and multiply. So we're going to take the reciprocal of the divisor and multiply. So here's our example. We have x squared minus 2x minus 8 over x squared minus 9 divided by x minus 4 over x plus 3. So go ahead and flip the second and multiply. And go ahead and finish this one on your own. It's the same as just multiplying rational expressions. So adding and subtracting rational expressions, it's a little bit different when we have the same denominator versus when we have different denominators. So when we have the same, we're adding and subtracting numerators, placing the result over our common or same denominator, and then simplifying. So here we have a subtraction of two rational expressions. So we're going to take the numerators, put them together, so we have 5x plus 1. And it's important to remember that the negative from here is applied to the whole term. So we're going to make sure to keep this outside the parentheses and then distribute it to both terms. So we end up getting 5x plus 1 minus 4x plus 2. And then here we can combine like terms to get x plus 3 over x squared minus 9. Then we could factor the bottom, which is the difference of two squares. And then we could cancel out the x plus 3 and this x plus 3. So we get 1 over x minus 3. Our domain, therefore, is x cannot equal negative 3 and x cannot equal 3. So when we have different denominators, we want to find the least common denominator. Factor out each denominator and then take the product of the distinct factors to get the LCD. And then we want to multiply the numerator and denominator by that least common denominator in order to convert it to the least common denominator and essentially multiply by 1. So here's an example to demonstrate. We have x plus 3 over x squared plus x minus 2 plus 2 over x squared minus 1. So we can see here that the left term or the left expression is missing an x plus 1 in the denominator once we factored it. So our right term was a difference of two squares. Our left term was a polynomial that we factored. So we're going to go ahead and multiply the left term by x plus 1 over x plus 1, which is 1. And then our right term by x plus 2 over x plus 2. And that is because our least common denominator is all the terms that make it common or that they're missing in order to be the same. And then we go ahead and multiply those to the top. So we have x plus 1 times x plus 3 and then 2 times x plus 2. And then we add them like we would a fraction. So, and then we have to distribute here and here. So go ahead and do that and then add them. And then we have x squared plus 4x plus 3 plus 2x plus 4. Then I'm just going to write denominator because it's so long. And then simplifying that and combining like terms, we get x squared plus 6x plus 7 over that denominator. And we know we can't simplify anymore because when we do our x method, there aren't any terms that satisfy. So it cannot be factored. So we just leave it like that. So for compound fractions, these are fractions where the numerator, denominator, or both are fractional expressions. So here for our example, we're going to look at the numerator and denominator separately first. So we're just going to look at our numerator. So we have 1 plus 1 over x. So we're going to combine these by doing our common denominator. So we're going to multiply 1 over 1 times x over x. And then this gets us x plus 1 over x. And then our denominator, we're going to do the same thing, the common denominator. And this achieves x minus 1 over x. So now we're going to combine those two answers back into our numerator and denominator. So we have x plus 1 over x minus 1 over x. And I like writing it out in a straight form just to see everything at once. And so it's easier for me to flip the second and multiply. So we're going to have x plus 1 over x times x over x minus 1. We're able to cancel these x's, and we end up with x plus 1 over x minus 1. So our last thing is rationalizing the denominator or numerator. So the radical conjugate of a plus b square root c is a minus b square root c. So we're basically just negating the second term. So if it's positive, here it's going to be negative. If it's negative here, then here it's going to be positive. So for example, we have square root x plus h minus square root x over h. And this is a common expression that's used throughout calculus. So that's why I pulled this example. But so we know our conjugate is square root x plus h plus square root x. So we're going to go ahead and rationalize the numerator. So we're going to multiply by our radical conjugate on the numerator and denominator, which is essentially multiplying by 1. So we get this big long thing after we distribute here. So we're going to do that, and then we get square root x plus h squared times that and that, but those two cancel. And then we're going to multiply negative square root x times square root x. So our negative stays out here. Then we're squaring this whole thing. And then we just multiply the denominator. And now we can square these terms. So our x plus h squared term, this cancels that. So we're left with x plus h. This cancels that. So we're left with negative x. So our x's cancel. We're left with h over h times square root x plus x square root x. So the h is canceled as well. And so our answer is 1 over square root x plus h plus square root x. So our h cannot be equal to 0. Otherwise, we'd have a 0 denominator. So that's our domain here. And that's it for our section 1.4 and our Monday lectures. So I'm going to be posting up more lectures on Wednesday, and make sure to be reading the textbook from the readings that I posted from the first lecture video. I'm going to post up our first homework on Wednesday, and then that'll be due next week on Monday. In the future, I'll have the homework earlier, but this week I have it a bit later, but hopefully it won't be too bad, and the lectures and the textbook will be helpful. If you guys have any questions on the lectures or any of our videos, textbooks, or homework, please come to my office hours or email me. Sometimes if I find a question relevant in an email, I'll send it in the Canvas to the rest of the class. But other than that, I'll send you emails about our quiz. I may have a practice quiz on Friday just to get used to posting the quizzes there, but I will definitely email you guys and let you guys know. Okay, I'll see you on Wednesday. Thanks so much, guys. Bye.